17.3 Conservative vector field. Evaluate the line integral for the full-length function and oriented curve using a parametric description of C and evaluating the integral directly, and B using the fundamental theorem of line integrals. So del or whatever phi xy is pretty much xy, and rt, the limits of parametrization, that's going to be cosine t sine t for 0 t 3 pi over 4. So straight up, f dot dr is pretty much f dot r prime of tr, and whereby r is this from a to b. So a and b, put it back here, right? So phi of the function xy is pretty much the partial of, say, x and the partial of y, but in separate coordinates. So calculating the partial of this function over here, you're going to get for the x coordinate, you're going to get y, and for the y coordinate, you're going to get x. And when you parameterize based on this equation over here, or this series over here, you're going to get sine t cosine t. So since we established that rt is cosine t sine t, r prime of t, it just respectively as they are, is negative sine t cosine t, right? So f dot r prime of t is, remember these are f over here, sine t cosine t dot r derivative, so negative sine t cosine t, and you get cosine squared t sine squared t. So cosine 2t using trig identities. So bring that cosine 2t over here, and your a and b, integrate negative half. Fundamental theorem of line integrals, so same thing, phi b, the last limit minus phi of the first limit. So remember b is 3 pi over 4, so sine of 3 pi over 4, negative 2 over 2, and root 2 blah blah blah, and the a, same thing, get the difference, add it up, that's your answer.